Example 3. Q of x equals x squared plus x minus 6 divided by x plus 1. Find the following. Start with the domain. Let's look at the zeros of the denominator. Well, there's only one, and that's at x equals negative 1. So that's our excluded value. So the domain is from negative infinity to negative 1, union negative 1 to infinity. For wholes, let's factor this numerator. It's be x plus 3 times x minus 2, because 3 times negative 2 will give me negative 6, and 3 plus or minus 2 will give me positive 1. So we have no wholes because we have no common factors. So there's no wholes, but there is a vertical asymptote at x equals negative 1, the one and only 0 of the denominator. Now let's move on to horizontal or oblique asymptotes. So we need to compare the degrees of the denominator to the degree of the numerator, and I don't know why I wrote a greater than there, because that's not true. It's the opposite way. The degree of the denominator is less than the degree of the numerator. And furthermore, it's exactly 1 less than. So that means we have an oblique asymptote. So we have an oblique asymptote, and we need to do a little bit of long division. And remember, we don't have to do it all the way out. We just have to find the linear equation. So we have x squared plus x minus 6. We need to eliminate x squared, and we have an x to begin with, so x times x is x squared. X times 1 is plus 1x, and we're subtracting both of those. By design that eliminates, but x minus x gives me 0. I bring down a negative 6, and then what can we do here but just have negative 6? We don't even care what's left here. We're just going to have plus 0, so we don't need to write that. So our oblique asymptote is y equals x. It's the identity. Let's move on to intercepts. So to find the x-intercept, we plug in y equals 0. So we'll have 0 equals x squared. I'm going to write it in its factored form, x plus 3 over x minus 2 over x plus 1. It's really, we just have to look at the numerator though. So we can read the zeros of the numerator when it's already factored. So we'll have x equals negative 3 and positive 2. So we have the coordinates of negative 3, 0 as an intercept and 2, 0. Now the y-intercepts, that means we plug in 0 for x. So plugging in 0 for x, I'm just going to do it in the factored form again. I'll have 3 times negative 2 over 1, so that's negative 6. So I have 0 comma negative 6 is the y-intercept. Now with this many points and with our vertical asymptote, we might be able to sketch this graph fairly quickly. So again, you'll have to look at your notes while I scroll down on the screen. Now I have a vertical asymptote at x equals negative 1. I also have an oblique asymptote, y equals x, so I'll try to sketch that pretty accurately. So this is y equals x, and I just dashed both those lines to show that these are boundaries where the curves have to be between them. And then I have several points here. I have 2, 0 is an x-intercept. I have 0, negative 6 is a y-intercept. And I also have negative 3, 0 is an x-intercept. So this is enough information knowing that I can't cross these asymptotes, and I have to live either above or below the oblique asymptote. So I know with the left branch, I'm going to look something like this. I'm going to live between those two asymptotes, looking something like that. And then also to the right of the vertical asymptote, I have 2 points which define where the curve lives. And then I have to look something like that. So now we can read some information about the vertical asymptote behavior and the function itself. So as x approaches -1 from the left, f of x is going to positive infinity. As x approaches -1 from the right, f of x is approaching negative infinity.